Whoever you are, loitering in a Lagrange point, or auditing the Oort cloud. Hello. Full disclosure, I am wired on caffeine right now, as one is wont to be when considering galactic scales and distances. As promised, today we are talking about the universe, one of my favourite topics and adversaries. To do this proper, I'm going to be flipping the V's at my own self-imposed 20-minute runtime, for if there is one thing I know about the universe, she should not be rushed. Another thing that's important to realise is that scientific knowledge doesn't just belong to those who discover it. Cosmological understanding isn't only relevant to astronomers and astronauts. Embracing some hard facts of our existence and our place in the universe is a task for each of us, if only to keep things in perspective. It's also fun. What follows, then, is a kind of wiggle soup guide to the universe in a series of fun facts. Pop the kettle on. You'll definitely be wanting to stimulate yourself for this astronomical slap to the brain. Before we kick off, we should really calibrate our brains to cope with gigantic numbers. Let's start with 1,000,000. How long is 1,000,000 seconds? We don't have to wonder, I've got a calculator right here. 1,000,000 seconds is about 11.6 days. So, with that as a benchmark, how long is 1,000,000,000 seconds? If you thought 31.7 years, congratulations! Your mathematical intuitions are on point. Until about the year 1800, Club Homo sapiens simmered with a population of about 1,000,000,000 members. When I first conceived of this episode as a Wiggle Soup blog back in October 2019, the human population of the world was astride over 7.7 billion people. Today, we're just over 8.1 billion. I'll put a link to the world's population clock in the description, but be warned, watching the world's population exponentially rise in front of your eyes is horrifying. Now let's consider another number, 100 billion. That is a big number. 100 billion, by some estimations, is the total number of human beings who have ever lived on planet Earth, depending where you draw the line between ape and man. If this is a difficult number to digest, consider that 100 billion is also approximately how many individual microbes live within a gram of fecal matter. Every gram, I should say. Assuming each of us beautiful human specimens carries a kilo of intestinal slurry around inside of us, the gut bacteria in one single person easily outnumbers the cumulative totality of humankind 1,000 times over. And this is almost certainly an underestimation. You are an ecosystem, my friend, a universe unto yourself. Think about it. One bacteria per human who has ever lived, per gram, per flush. Now that we've bigged ourselves up, it's time to redress the balance with an intergalactic perspective. As a child, I remember being totally blown away by a popular science fact about rainbows. The thinking goes, everyone who looks at a rainbow sees a different rainbow, unique to them from their perspective. You see, a rainbow is created when light disperses through raindrops. Because your eyes occupy a different position in space to anybody else's, nobody can see the same rays of reflected light as you can. Therefore, they cannot see the same rainbow. QED. A few years later, the profundity of this fact was somewhat diminished when I learnt that what's true of rainbows is basically true of everything you can see. A person's geographical position is theirs alone, so light reflected towards their eyes from any direction is registered by their eyes only. If others happen to agree on the exact location and description of visible objects, they're doing so with light gathered independently. Come to think of it, the same applies to each one of your eyes. Look at that beautiful mug of coffee in front of you. If you cover one eye and then the other, you make it jump left and right as you cover each eye in turn. You can pass a lot of time doing this. The mug isn't shifting, only your perspective, unless it's a really strong cup of coffee. With the rainbow wool pulled from my eyes, romantic-sounding science facts would have to work a lot harder in future to impress me. So, when I first heard science communicator Brian Cox describing people as being made of stardust, I didn't immediately fist pump the air. The science behind the claim is sound. Every atom in the universe, at least those heavier than lithium, was made inside a star. This includes carbon, oxygen, and every other element needed to build a human. Stars are the only places with high enough temperature and pressure to crush atoms together, fusing them into heavier and heavier elements. These raw ingredients only escape when the parent star explodes, scattering elemental dust across the cosmos. It is true, then, that we are all the products of exploded stars. We are all stardust. The poetry is either enhanced or lost, however, when we realise that what's true of us is true of everything else in the universe. Planets, oceans, hagfish, coronavirus, and even that caked brown smear of bacterial habitat that someone left in a public toilet for you, it's all stardust. Brian. Personally, I find the idea that all the matter in the universe is composed of the same 94 elements to be far more awe-inspiring. Living things, like gerbils, are made of the same stuff as non-living things, like rocks, only in different ratios and with different chemistry going on under the hood. I'll be talking about this in depth next episode, but for now, consider that if there is alien life on some distant planet, it will be made of the same chemical components as terrestrial life, and be limited by the same universal laws of physics and chemistry. That's cool! In fairness, it was the legendary Carl Sagan who first popularized star stuff as our direct connection with the cosmos. But it's what he said immediately after that that truly blew my mind. Quote, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." This must be one of the most profound, gratifying, and uplifting truisms I've ever heard. It seriously woke me up. If you have no idea what this Carl guy is talking about, or if you simply thirst for more, a sucker for profound facts, I'm going to try to deliver my take on the cosmic perspective, with each progressive step moving us closer towards, now I get it. I'll put the Wiggle Soup pips in between each one, as these amazing facts need to be sipped and savoured like a shot of espresso, until the migraine makes you cry. Okay, shot 1. The Big Bang is not a theory of how the universe got started. Nobody knows how that happened, especially those that claim to. It's currently beyond the best tests that we have. Instead, the Big Bang actually describes what must have followed immediately after that moment of creation to give rise to the cosmos we see today. Modern astrophysics reliably accounts for and predicts the entire 13.772 billion year evolution of the universe. What it can't account for, what it can't touch, is the first 10 to the minus 44 seconds of creation. That is an infinitesimally small amount of time. So there's room for improvement, but Big Bang cosmology is still an astonishing achievement. Shot number 2. Whew. There is a definite point on any globe where progress north stops making sense. We call that bit the North Pole. No matter where you start from, everything heading north eventually hits a singularity. In this case, it's the infinitely small point where all northbound traffic converges. Now, believe it or not, the same is true for time. Time began with its own singularity at the Big Bang. Asking what happens before that point is like asking what lies north of the North Pole. The question is nonsensical. We good? Okay. Shot 3. Infinity comes in many different sizes. For example, there are an infinite number of numbers. You could try counting up from 1, or you can just take my word for it. If you thought it would take a long time to count to 1 billion, ho-ho, 1 billion's got nothing on infinity. Now, I have it on good authority that half of all numbers are even numbers, and there are still an infinite number of those. So infinity divided by 2 is still infinity. Even between two numbers, there are infinite divisions. Try counting from number 1 to number 2, including all decimal points. You will never reach 2. Honestly, if you even reach 1.002, you've cheated. Numbers can be thought of as sitting on an infinite one-dimensional line. What about 2 dimensions? An ant crawling across the surface of a marble could continue forever, if its lifespan permitted. No edge or boundary would end its fruitless march. Expand that marble to the size of a planet, and the same applies. The planet's surface is much bigger than the marble's, but both are still infinite in every direction. And it's the same with 3-dimensional space. At the Big Bang, the universe was tiny, smaller than whatever it is you're thinking of, but it was still infinite. Our universe has been expanding ever since time began, and that expansion is actually getting faster. But the universe has never not been infinite. It's just a bigger sort of infinite now than it was when I started this sentence. Alright. Shot 4. This one's quite difficult to describe, but I believe in us. Sit up, blink, here we go. A hiker can set off west as briskly as she likes and never make any progress north. You with me so far? Visualize this like drawing a line across a map, if you want. Changing direction slightly, the hiker now travels at the same pace northwest. This will halve her speed in the westerly direction, as progress will be shared equally between west and north. Finally, heading directly north, all westerly advance will reduce to 0. Her motion across the map is 100% north. Where am I going with this? Well, intuitively, this logic also applies to a 3-dimensional space. While moving through length, width, and depth, each axis will receive a share of the mover's total motion. Counterintuitively, this principle also applies to time. Remember from last episode, time and space are inextricably woven together. This space-time is one of Einstein's many contributions to our understanding of the universe. Oh yeah, Einstein was a smart one. He saw that if you switched your northwest axis to space and time, some interesting predictions could be made. Plotted as a space-time graph, a person standing perfectly still would only make progress through the time axis. The moment they start moving in any direction, progress through time is lessened, shared between the two axes. Simply put, the faster you move through space, the slower you move through time. Just like when we started moving northwest on our map from before. Experiments have repeatedly verified this prediction, revealing something quite amazing. The universe imposes a strict speed limit. This isn't just theoretical, it's literal. As you continue to accelerate, all progress gets converted to speed, with nothing left over for time. Hitting that cosmic maximum that we call the speed of light, a traveller's progress through time eventually diminishes to zero, at which point time is left standing still. Moving faster than this is like trying to go north of the North Pole, or trying to prevent your own birth. It's misconceived. What does all this mean for us sentient stardust? Where does our planet fit into the whole cosmic disco? Applying what we know, light travels very fast, about 300 million kilometers per second. But it is not instantaneous. Light from the sun takes about 8 minutes to reach Earth. It is 8 light minutes away. So when you look at the sun, please don't do this, its appearance is always 8 minutes out of date. Planet Jupiter, the largest planet in our solar system, is 43 light minutes away from the Sun. The edge of the entire solar system? That would be 1.87 light years away. Now that we have a grasp of cosmic distances, what about cosmic scales? I think we're ready for shot 5. How big the world is usually depends on what people are selling, but Wikipedia says that the Earth has a diameter of 12,742 kilometers. This means that it would take a little over 10 planet Earths lined up, Newton's cradle style, to span the diameter of Jupiter. Keeping with the theme, it would take 10 Jupiters arranged side by side to span the diameter of the Sun. You don't need me to tell you that the Sun's gravitational influence, aka the solar system, reaches a lot further than the planet Jupiter. But how much further? Imagine that the Sun was shrunk down to the size of a grain of sand. On this scale, the entire solar system, its planets, moons, asteroids, and earthling junk, might fit on a dinner plate. Earth would be a speck of dust 100 times smaller than that central sand grain sat practically touching it. Neptune, the furthest planet out from the Sun, would sit about a quarter of the way out from the centre of the dinner plate. Now that we can visually comprehend this snack-sized solar system, how big would our galaxy be on the same scale? The Milky Way, our galactic stomping ground, would be the size of North America. If this shot of cosmological caffeine doesn't leave you feeling just a little bit dizzy, you should go back and listen again. The nearest star to us, other than our Sun, is Alpha Centauri, and it is 4.4 light years away, across a vast desert of interstellar nothingness. The Milky Way is an epic 100,000 light years across, strewn with billions upon billions of stars spread out like grains of sand across the USA. This illustrates just how much space there is up there. If all this information doesn't make you feel rather small, remember that our Sun, our galaxy, and our spot in the celestial neighbourhood are in no way special. The chunk of universe that we can see, cryptically called the observable universe, contains over 2 trillion other galaxies. That's 20 entire galaxies for every human who has ever existed, each one sporting its own incalculable number of stars and planets. And before you ask, yes, that's just the observable universe. Because light has a fixed speed, it can only have travelled so far in the 13.772 billion years since the universe began. Light emitted by anything over this cosmic horizon, which is certainly most of the universe, can never reach us. The continuous expansion of space forever prevents it from reaching our eyes. And that, by the way, is why the night sky appears black in every direction. Just FYI. So what does humanity stand to gain from these insights, other than a collective headache and a sense of existential triviality? Reading popularized accounts by authors such as Brian Greene, Lawrence Krauss, and Neil deGrasse Tyson typically make me recoil at the staggering emptiness of our cold, practically lifeless universe. But composure regained, their frontline understanding of astrophysics delivers a payload of reverence, humility, enlightenment, and maybe even redemption. I'll walk you through the thinking. First, reverence. Why? Because the beauty we attribute to planets, stars, and galaxies is owed entirely to a handful of physical laws. These phenomena are not singular events, but unstoppable processes that began with the Big Bang and continue to this day. And at some point, they've enabled the emergence of life with blind indifference. You see, the forces of nature that fuse atoms and explode stars also created you, and your appreciation for cosmic aesthetics. For the last 2 million years at least, to use Mr. Sagan's words, we are a way for the universe to know itself. Which means, for the last 2 million years at least, the universe has been unfolding to the sound of its own trumpet. Accepting the universe as the dark, lonely, hazardous place that it is, without kidding ourselves that it is in any way tailored to our biological needs, ought to give us a heavy dose of humility. With this revelation, the trials, pursuits, and whims that choreograph our lives are blown away like candle smoke. Instead, cosmic truths scream for us to re-evaluate ourselves and strive for ever greater human solidarity. At least, that's what they scream to me. But after this many coffees, I'm starting to hear colours. Keep in mind that our tiny wet rock may be the only one capable of sustaining us. If so, life is as precious as the Earth is precarious. Continuing to ravage this planet the way we are is unconscionable, sickening, and deeply sad. So to enlightenment. Coming to terms with the nature of the universe puts the peculiarity of our lives at front and centre. The intrinsic reward that we derive from money, sex, esteem, and ambition suddenly looks a little childish. In closing, observing who we are, where we come from, and where we're heading through the eyes of the cosmos might just redeem our childish little species. To understand what I mean, consider that from subatomic particles like quarks and photons up to the scale of atoms and molecules, complexity increases. Each level that we ascend comes with new rules and new principles, none of which violate the basic laws of time, space, and entropy underneath. Progressing from molecules to cells, brains, emotions, consciousness, and creativity, everything that we see comes fizzing out without direction or guidance. More dynamic and unpredictable systems on larger scales like organisms, societies, ecosystems, and economies give rise to yet more emergent properties. Accidents, adaptations, selection pressures, and historical trajectories involve a torrent of interactions all feeding back on each other. The universe sure is a complex beast, but it does not require fundamentally complex parts. Over the last 3 episodes, we've seen that us humans are just part of the chaos that emerged from order. We, gazing up at the stars, debating the meaning of it all, are the universe finally coming to know itself. We are special in that respect, rare, if not unique in our cosmological comprehension. Once again, humanity finds itself elevated. Go us! We ran pretty long there, but I hope you'll agree, if one thing is worth doing properly, it's the universe. Now that we've covered how particles produce atoms and atoms create molecules, we're ready to see how geochemistry makes way for biochemistry. Next episode, I'll be thinking about the origin of life.